want you to take a second and think back to your high school chemistry or physics classes. What if one of the foundational facts of modern nuclear physics might actually be based on a massive, almost unimaginable leap of faith? So, okay, let's unpack this because we're looking at a truly fascinating document today. It's the detective-like look at Ernest Rutherford's legendary 1919 experiment.
And what's fascinating here is that the mission of this deep dive isn't to tear down a legendary scientist. I mean, Ernest Rutherford was undeniably a brilliant mind,
Yeah.
right? A giant in his field.
Yeah.
Instead, we're going to treat this document like a scientific cold case. We want to unpack whether Rutherford actually achieved what the textbooks say he did.
The first transmutation of nitrogen-14 into oxygen-17?
Exactly. Or, if this represents one of the greatest scientific overreaches in history, it really forces us to look closely at how science is actually done and how those conclusions eventually harden into dogma. True scientific literacy requires questioning assumptions, even the ones that have been entrenched for over a century.
It shows how even the absolute brightest, most rigorous minds can sometimes see exactly what they want to see. In our modern era of total information overload,
Where we're bombarded with data and claims every single day.
understanding how a massive conclusion can be built on tiny, questionable inferences is a crucial lesson. So let's set the scene. The year is 1919, and Ernest Rutherford is supposedly playing the ultimate accidental alchemist. What was he actually trying to do when he set up this experiment? Because he didn't set out to make oxygen, did he?
No, not at all. His working hypothesis was completely destructive. He wasn't trying to build a heavier element or play creator. He just wanted to disintegrate a nitrogen-14 nucleus.
Just smash it.
Exactly. His method for doing this was to bombard nitrogen gas with alpha particles, which are essentially helium nuclei.
Okay.
Think of it as firing tiny, high-speed atomic bullets into a cloud of nitrogen atoms. He was expecting the nitrogen to just shatter under the extreme kinetic force of the impact.
And I want you to picture the apparatus he was using, because when we hear about particle physics today, our minds immediately go to massive, multi-billion-dollar underground rings of superconducting magnets, like CERN.
Oh, sure, the Large Hadron Collider.
But Rutherford was using something called a Wilson cloud chamber. Can you explain what that actually is? Because it sounds incredibly rudimentary compared to what we use today.
It is incredibly rudimentary. I mean, a Wilson cloud chamber is essentially a sealed glass container filled with supersaturated vapor. In the chamber, they would suddenly drop the pressure, which cools the air.
Okay.
The vapor wants to condense into liquid, but it needs a seed, something to cling to. When a charged particle, like an alpha particle, zips through that chamber, it ionizes the gas along its path.
So those ions act as the seeds.
You got it. The vapor instantly condenses around them, leaving a tiny, momentary trail of mist. It's very similar to the white contrail you see behind a jet, flying high up in a cold sky.
And from that setup, he presented a foundational equation to the world. The math at the heart of his claim is that 2 helium-4,
The alpha particle bullet,
right, plus 7 nitrogen-14
the target,
results in 8 oxygen-17 plus 1 hydrogen-1, which is a proton. He claimed the alpha particle embedded itself into the nitrogen nucleus, created a heavier oxygen isotope, and kicked out a proton in the process.
The evidential threshold should be astronomically high. In science, you look for repeatable, overwhelming data to support a paradigm-shifting claim like that. But the author suggests that what Rutherford actually had was a statistical needle in a haystack.
And from that single needle, he built an entire theoretical barn.
Precisely. It's a story of incredibly rare, anomalous events being elevated to unquestionable truth.
When he was firing these alpha particles into the nitrogen, more than 99.999% of them bounced off exactly as expected.
Yep. They hit the nitrogen nucleus and ricocheted away, creating a very standard, predictable Y trajectory in the mist. The vast, overwhelming majority of interactions were simple, elastic collisions. To picture an elastic collision, just imagine 2 perfect billiard balls hitting each other on a pool table.
They strike, bounce off, and go their separate ways.
Right, without losing kinetic energy or breaking apart. The alpha particle goes in, strikes the target, and scatters. It leaves a clear, observable deflected path. But then
we get the anomaly.
Exactly. Out of tens of thousands of tracks reviewed,
We're talking literally less than 0.00000 or more % of the observations here.
showed something different. An alpha particle went in, but an alpha particle track was not observed coming out.
And it's fascinating to learn who actually spotted this needle in the haystack, who was squinting at all these momentary mistrails.
It was his assistant, Patrick Blackett. Blackett was tasked with reviewing roughly 23,000 photographic plates taken of this cloud chamber. And out of all those thousands of photographs, Blackett caught sight of just 8 anomalous tracks.
8 out of 23,000.
Right. They saw a specific track emerging from the collision point that was shorter and thicker than the typical track of a proton.
Okay, so a short, thick track.
And because it was shorter and thicker, they inferred that it must be a heavier, slower-moving particle. They concluded that this modified residual nucleus had to be oxygen-17.
Wait, so they see one weird track out of thousands, well, 8 weird tracks, and just assume it's a completely new element.
That is what the source document is pointing out, yes.
Yes. You're firing tens of thousands of atomic bullets. Almost all of them do exactly what you expect. Then, 8 tracks look a little short and thick, and from that, you declare to the world you've achieved elemental transmutation. A foundational physics principle that we still teach today was based on a statistical anomaly so unimaginably small that modern experimental physics would likely treat it with extreme caution.
They'd probably assume it was an error in the equipment.
Or just a random statistical fluke. It raises a very serious question about how we interpret chaotic data. And the source text uses some brilliant analogies to illustrate why jumping to the conclusion of a perfect atomic merger is logically fraught. Let's talk about the car crash one first. The author brings up this idea of a car crash to argue against the collision-based perspective.
Right, the conventional view assumes that slamming 2 atoms together at high speeds perfectly merges them.
But if you take 2 cars and crash them head-on at 80 miles an hour, you don't expect them to neatly fuse together into a third, bigger, enhanced, perfectly functioning car.
No, it's not a feasible growth dynamic.
You expect wreckage. You expect twisted metal and parts to fly everywhere.
It really highlights the strange assumption that extreme violence leads to perfect structural coherence. And the second analogy regarding the alpha particle is just as striking. The cue ball analogy. Think about it. If you're playing pool and you hit the cue ball into the pack for the break-off, how many times have you ever seen the cue ball just vanish?
Never.
It hits the pack, the other balls scatter, but the cue ball always remains on the table. In Rutherford's anomalous tracks, the alpha cue ball seemingly disappeared without a trace, which defies basic mechanical logic.
And that vanishes without a trace detail leads us to the biggest bombshell in the entire document. Oxygen-17 was never actually observed or isolated in this experiment. Never.
That is the crux of this entire scientific cold case. They never bottled up the oxygen-17 and proved it was physically there. The presence of the oxygen was entirely inferred.
Wow.
And the source text outlines a massive lack of secondary evidence that really should have been present if a transmutation actually occurred. First, there's the Coulomb electrical nuclear force to consider.
Okay, let's break down the Coulomb force because that sounds a bit intimidating.
Think of trying to push the north poles of 2 incredibly powerful industrial magnets together. As they get closer, they repel each other, pushing back against your hands with this invisible force. That's the Coulomb barrier. It's the massive repulsive electrical force that prevents positively charged atomic nuclei from just easily merging into one another.
So they don't want to touch.
At all. For the incoming alpha particle to overcome that intense magnetic repulsion and physically penetrate the nuclear body of the nitrogen atom, that a nitrogen target would have to remain perfectly rigidly positioned.
Which, in a rudimentary glass cloud chamber filled with gas.
Capturing that exact perfect alignment is statistically improbable.
Okay, but let's play devil's advocate. Let's assume the impossible happened. The alignment was absolutely perfect. The bullet hit the target dead center and it penetrated the barrier. The source says we still have a huge problem with the lack of subsequent proof. If this violent merger of particles actually happened, creating a brand new, heavier element, there should be a physical signature of that creation, right?
Absolutely. In nuclear physics, when elements transmute or absorb massive amounts of kinetic energy, there's a release. There should be subsequent decay products.
Like what?
We would expect to see gamma emissions, a flash of light, or some kind of spectral anomaly radiating from the newly formed oxygen isotope.
But Rutherford and his team reported
Absolutely none of that. No fragmentation, no noticeable recoil energy, no slash.
it's the equivalent of claiming a massive explosion occurred in a small room, but when you open the door, there's no heat, no sound, and no smoke.
How did they arrive at the conclusion of oxygen-17? The text explains that Rutherford essentially reverse-engineered the math based on mass balancing.
Because the equation had to balance on paper and the alpha particle went missing visually, he just assumed the invisible leftover mass was oxygen.
Yes.
That's a massive leap. He knew what he put into the chamber. He fired the alpha particles. He assumed he had a perfectly pure source of nitrogen-14 gas inside the glass.
Right.
And when Blackett saw that long, streaked wake in the mist, Rutherford confidently recognized it as a proton.
Yep.
Because the alpha particle vanished from the visual track, he just did the arithmetic. He assumed that whatever mass was left over simply had to be oxygen-17 to make the numbers work.
He assumed his inputs were perfectly pure and correctly identified. He assumed the proton track was definitive proof of nuclear alteration, and he inferred the rest to make the ledger balance. But the author is careful to point out that there is no questioning the personal integrity of Rutherford or Blackett. They weren't being deceitful or faking data.
Right, they believed what they saw.
They just conferred the highest possible statistical value onto a minuscule number of anomalous visual results and elevated them to a very ambitious, world-changing conclusion.
Which brings us to a fascinating pivot in our source document. It starts questioning the very foundation of how we view atomic physics. Conventional physics treats matter like a set of interlocking bricks. The orthodox interpretation assumes that if you want to build bigger, heavier elements, you just slam smaller particles together at incredibly high speeds to force them to interlock.
But the author challenges that very premise. Does violent collision really lead to increased coherence and stability in the recipient material?
It's a fundamental question about the nature of the universe.
And to drive this point home, the text uses Rutherford's own words to highlight the inherent contradiction in his conclusion.
In his own papers, Rutherford wrote, "Considering the enormous intensity of the forces brought into play, it is not so much a matter of surprise that the nitrogen atom should suffer disintegration as that the alpha particle itself escapes disruption into its constituents."
Hearing that quote is staggering.
Rutherford is openly wondering why, in this unimaginably violent collision, the nitrogen atom breaks apart and yields a proton, but the alpha particle, the incoming helium bullet, survives completely intact to embed itself in the wreckage.
Why doesn't the alpha particle shatter as well?
It's a glaring logical inconsistency. If the impact is so intense that it blows a piece off the nitrogen, the helium bullet should be obliterated too.
So if it wasn't a clean, perfect transmutation, what else could have caused those tiny handful of anomalous tracks in the mist?
The source material offers several alternative explanations. One of the most prominent is the idea of photoelectric ejection.
Right, photoelectric ejection.
Essentially, this suggests that the kinetic energy of the interaction could have caused a proton to be ejected from the nitrogen through a different mechanism entirely.
One that doesn't require the nucleus to absorb the alpha particle and transmute into a new element.
Think of a powerful explosion going off near an apple tree. The shock wave of the explosion might be enough to knock an apple off a branch, even if the shrapnel never actually touches the tree.
The energy transfer alone causes the ejection.
That makes a lot of sense. The energy of the near-miss collision knocks a proton loose, but the nitrogen doesn't turn into oxygen.
Introducing a concept that connects back to one of the most brilliant and unconventional minds of the 20th century.
Nikola Tesla.
Yes, the source introduces this mind-bending idea about feedback loops and resonance.
To understand the Tesla connection, we have to look at what Rutherford was actually doing physically in the laboratory. He wasn't just firing one particle and taking a picture.
No, he was firing alpha particles continuously, constantly, through the exact same tiny aperture into the exact same confined space of the Wilson chamber, along the same pathways, hour after hour.
And the text argues that doing this must impact the trajectory field, creating a feedback response. It brings up Nikola Tesla, who famously stimulated a mechanical coil into resonance by exciting it at exactly the right time with small, rhythmic pulses.
The suggestion here is that the Wilson chamber wasn't just a passive glass box where collisions happen in a vacuum. By constantly firing these particles into the space, Rutherford was effectively pinging the lattice. It's essentially acoustic resonance applied to particle physics.
Like striking a tuning fork in a small room.
Exactly. At first, it's just the fork vibrating, but if you keep striking it perfectly in rhythm, eventually the acoustic properties of the room itself begin to respond. The walls might vibrate, the air pressure stabilizes into a standing wave.
So the source is arguing that the continuous stream of alpha particles was generating a resonance signal within the chamber that Rutherford completely failed to take into account.
What looked to him like the passive pumping of atomic bullets might have actually been exciting the local field in entirely unexpected ways. The environment itself was reacting to the rhythm.
If the field inside the chamber was in a state of resonance, those few anomalous tracks, the disappearing alpha cue ball, the strange proton wake, might not be evidence of transmutation at all.
They might simply be artifacts of a resonating, highly excited environment.
The chamber was tricking the observer.
Exactly.
We've taken Rutherford's incredible 1919 experiment, we've stripped it down to its incredibly rare visual anomalies, we've established the oxygen was never actually observed, and we've introduced the idea of Tesla-like resonance altering the local environment. Why does this century-old debate actually matter to us today?
It matters because the anomaly isn't actually what Rutherford and Blackett observed in that tiny fraction of track. The true anomaly is what they claimed was proven from those tracks. As the source states, if this exact paper, with this exact methodology, inferential math, and lack of secondary physical evidence, were presented by an unknown researcher to the scientific community today, modern peer review would demand independent verification. They would demand reproducible supporting data, isotopic isolation, and a clear accounting of the energy release, not just reverse-engineered arithmetic.
It's a powerful reminder to question settled facts. Just because a diagram has been printed in a textbook for 80 years doesn't mean the foundational data isn't hanging by a thread.
We have to understand that inference is not proof. Making the math balance neatly on a piece of paper doesn't mean you've accurately captured the chaotic, complex reality of nature.
It really encourages a mindset of healthy, rigorous skepticism. In a world driven by flashy headlines and definitive scientific claims, we must always look for the underlying data.
Is it reproducible? Is the physical evidence actually there? Or is it a statistical fluke being paraded as a paradigm-shifting breakthrough?
If the Tesla resonance theory holds true, could the future of physics and limitless energy rely not on violently smashing atoms together to see what breaks, but on finding the right acoustic and harmonic frequencies to gently coax matter into new forms? Think about that next time you look at a perfectly neat physics textbook. Until next time,